Woo! Welcome to another installment of Boss Stetler Production. Classifying triangles. Okay, well, guess what we're going to do? We're going to classify triangles by their angle measures and their side lengths. Before we go into classifying, though, I want to talk about the parts of a triangle, right? So we got three sides, right? And those sides are AB, BC, and AC. And we have three angles, angle A, angle B, and angle C. So those are the parts of a triangle. These are also called the vertices, and these are called the legs. Okay, so let's just talk briefly about the types of triangles we have. We can classify triangles two different ways, okay? You got it? Two ways to classify triangles. First way is by its angles. The second way is by its sides. So when you're talking about types of triangles, you could be referring to their angles or you could be referring to their sides. So the first type of triangle that I want to talk about is I want to talk about classifying them by their angles. So we have a couple of those. The first one that I want to talk about is the acute. An acute triangle is a triangle whose angles are all acute. Angles are all acute. Okay, obtuse. Only one angle is obtuse. We can't have more than one because their sum equals 180. And if for them to be equal to 180, there can only be one obtuse angle in the triangle. We also have the right triangle, which you know what that is. A right triangle only has one right angle for the same reason as the obtuse one. And then we have the equiangular, which means all the angles are congruent. So equiangular. I'll spell that for you. Equiangular. All right, now let's talk about sides. By their sides is the ones you usually refer to them as. You refer to them as scalene, which means no sides equal. Okay, they're not equal at all. Isosceles. Okay, isosceles means not just two. Okay, most of the time people think two. That's not what isosceles means. Isosceles means at least two. Okay, sides are congruent or equal. We can call it congruent or equal. So, questions on that, make sure you're ready for tomorrow. I'm going to ask you a little bit about isosceles triangles. So at least two sides are congruent. And then you have the equilateral, where all sides are congruent. Now, when I say, what I want to ask you real quick is, since this says at least two sides are congruent for isosceles, does that mean that equilateral are also isosceles? Be ready to discuss that then. All right, so let's do this example. This example is pretty simple, pretty straightforward. We're going to classify triangle BDC by its angle measurements. So you need to make sure that you understand it's either going to be acute, equiangular, obtuse, or right. So what I'm going to do is I'm just going to highlight BDC to kind of make it a little bit differentiated between the rest of the triangles that are in the shape. If you look, angle BDC is acute, okay? This one right here, it's less than 90. But angle DBC, which is this angle up here, is 100. Since it's 100 degrees, we can classify it as obtuse. Okay, for this example, we want to classify triangle ABD by its angle measurements. Now, let's just go ahead and highlight that angle ABD. Now, 80 is pointing to this angle right here, and 20 is pointing to this angle here. We cannot just assume that this angle is smaller than 90. We have to figure out what it is. In order to do that, we have to understand that the sum of these is 180. Okay? The sum of all the angles in a triangle is 180. So you need to know that. 20 and 80 make 100, right? So that means that this other angle has to be 80 degrees. And since it's 80 degrees, we can now say it's acute because all the angles are less than 90. Okay? Okay, last one that I want to do with you, we're going to classify angle FHG by its angle measurements. So if you look at it, we have two 60s at the bottom. So we have to figure out what this one is. We cannot just assume that it looks like it might be 60 because we have to make sure it is, or we have to make sure what it is, okay? So what we notice is we have a 90-degree angle right here. That means that with 30 degrees plus this angle, whatever it is, better equal 90, right? So that means 90 minus 30 gives you the angle that's inside of here, which is 60. Now, you may ask, Mr. Bostetler, why aren't these just acute? Well, because they're all equal, then I'm going to call it equal angular because it's better. It's more specific, okay? So it has a better name then. So we're going to call it equal angular. And then we're done. Okay, we're going to switch some things up here. We're going to talk about the sides, okay? So things can either be isosceles, okay, which means at least 2. It can be scalene, which means 0. Or it can be equilateral, which means that the triangle has all equal sides. Okay, so when I look at this, I'm looking for this particular triangle, and we're classifying it by its side lengths. So EHF. EHF is this triangle right here. Okay, so we look at these little slash marks and we notice that these sides are congruent. Well, that means that this has to be 10 then. And so since it's 10, we can call this isosceles because at least 2 sides, 10 and 10, are congruent. So this one's isosceles. Now we're going to look at triangle EHG, which is the whole triangle. Okay, we have a side length which is 12, we have a side length which is 11, and then we have this whole side length which is 14. 10 plus 4 being 14. Since all of them are different, then that means that it's scalene. All right, now we got to throw some algebra into it. Look at me, algebra. So what we need to do is we need to find all of the side lengths of this triangle. To do that, I got to find x. I got to know what x is. Okay. Well, how do I find it? Well, I take a look here and I notice that I have some tick marks. Well, those tick marks mean that these two expressions are equal, so I can set them equal. So 4x minus 10.7 equals 2x plus 6.3. Okay, so then you need to solve this, right? So what we're going to do is we're going to subtract 2x. We're going to get 2x minus 10.7 equals 6.3. We're going to add 10.7. We're going to get 2x equals 17. We're going to divide by 2, and we're going to get x equals 8.5. But we're not done yet, right? I mean, we have to figure out the side lengths. So what I need to do is I need to plug x back in to all of these. When I plug this x back in, I get 23.3, 23.3, and I get 44.5. So now I'm done, okay? What you should do is you should either show the picture with the lengths beside it, or you should write JK, which means length of JK, equals 23.3, KL equals 23.3, and JL equals 44.5. That's it. Okay, for our last problem, we're going to solve for all the side lengths of this equilateral triangle. Equilateral meaning same sides. So all three, right? All three have the same side. So that means that this is congruent to this, which is congruent to that. Correct? Yeah, I know because I'm right. So since it's congruent, I can either set any one of these equal to one of the other ones. Okay? So it doesn't matter which one I do, I can just pick one. So I'm just going to pick these two right here. So I'm going to do 3y minus 4 equals 2y plus 3. I'm going to solve for y by subtracting 2y from both sides, which is going to give me y minus 4 equals 3. Add 4 to both sides, and I get y equals 7. I'm not done because I want to find all the side lengths of this triangle. So to do that, I need to take this y and plug it in. Now, all of these should be the same. So you want to check it just to make sure, because you may do your algebra wrong and then you get the whole thing wrong. So you want to make sure that all of your side lengths are the same when you plug 7 in, and they are. They should all be 17. Okay, so that's it, man. So what you need to know is you need to know the types of triangles by their angles and by their sides. Okay, you need to understand that the term isosceles only means at least 2. Okay, it only means at least 2 sides are congruent. For all of our angles, okay, classifying by angles, we have the right triangle, we have the obtuse, the acute, and the equiangular. For sides, we have equilateral, isosceles, and scalene. You need to know the difference between all of them. All right, have a good night.